Hello and welcome to today's session. My name is Prasanjit and today I'll take you through Ansible configuration management. So in today's lecture, we would be essentially covering Ansible. It's a configuration management tool. I'll talk about that in the lecture, like what configuration management means, what is this tool Ansible, and how does it help us while we are managing DevOps practices. So the agenda would be understanding configuration management, understanding the various tools that come into play when we practice configuration management. Then we move on to understand how Ansible works. This is the particular tool we'll be covering in today's lecture. So we'll understand how it works and how we can implement it to help automate our processes and to help manage configuration and infrastructure. So we'll be covering that quite extensively, and apart from extensive coverage of Ansible, we'll also try out this exercises on AWS cloud, so that would give you a break from your normal virtual box, and you would also learn pick up a thing or two about the cloud and how we can create instances on the cloud and how we can deploy various software packages using Ansible. So that's what we are going to do today, and this would involve installing Ansible, running ad hoc commands and playbooks on Ansible, and we'll do this with certain hands-on exercises which I have prepared for you, and hopefully in the end of the session you will be able to know why Ansible is being used and how to get it implemented, so that whenever such a situation comes when you have to deploy certain things in remote servers, then you will be easily able to do it using your Ansible knowledge. So let's get started. First of all, before we go on into Ansible, let's first understand what configuration management is. So by configuration management, what do we mean? According to the Wikipedia definition, it's a systems engineering process for establishing and maintaining consistency of a product's performance, functional and physical attributes with its requirements, design, operational information throughout its life cycle. So this definition doesn't make much sense in layman's terms. So let me simplify this for you. So just imagine an example where you are the system administrator of a website, and your website is distributed across 50 different servers. So you have 50 Apache servers, and your particular web application is hosted in 50 different servers. You might be thinking, why 50? Say you have a huge traffic and a single server is not able to take care of that amount of traffic and serve it seamlessly. So you have 50 different servers and you have load balancers, and the requests are equally distributed between those 50 servers, and that's how your site is operating. So now comes the situation when you have to change something in the Apache configurations in your 50 servers, or say you have to add a new module. Say there was some new library that was introduced. Say your website is in PHP and you have a new library that was to be deployed on the Apache servers for a particular functionality to work. So your developer asked you to install that library on the server and then get the new code live there. So when doing that in normal practice, like when you do not use any configuration management tools, then you would have to make changes or do the installations in 50 different servers. So it will be a lot of overhead work. So you have to log into 50 servers 50 times and do the same thing again and again. So it's redundant, like you have to do the same things numerous times, and it's time taking, and there are chances that you might end up making some mistakes. So this is a situation where you would need configuration management. like you have a config ready and you know it's correct, it has been evaluated or tested in certain servers. Now you want it to be deployed across those 50 servers. So if you had a tool which could take care of this kind of a scenario, that would be a very welcome move. So we already have these kind of tools which we use as a part of DevOps practice, and Ansible is one of them. So let's look at this diagram. So here is the client, and say these are the servers, the compute instances. So you have 50 different servers stacked up here, and this is the client, like it could be your laptop, and you have your configuration here. Now you want to apply that particular configuration in all the 50 different servers. So if you do it yourself, you would have to SSH into each of these servers and make the change. Now this is not practical. So what will you do? You will use a tool like Ansible and put your configuration into the Ansible using various commands or using a playbook, and Ansible then manages its connection between all those 50 servers and applies the configuration change there. So in that case, like, there are multiple things that happen. One advantage is that your change is applied across all the servers uniformly because you're not doing any manual steps. So it's uniformly applied across all the 50 servers, which is a good thing. Another thing is, if you apply the same change again, intentionally or by mistake, then Ansible would remember the state of the particular deployment or the application of that particular configuration. So it would not do anything if that particular change has already been applied. So in that way, the state of a system is preserved. Or for example, if someone changes something, like if for example you have a Apache server and you made some changes using Ansible across the 50 servers. Now I enter one of the servers randomly and delete the config file from there or make certain changes. So in that case, if you run the Ansible script once again, it brings it back to the state it was in. So that way again it comes back to uniformity. So that's how a configuration management tools allows you to manage your configuration across multiple servers and also helps you retain the state of the particular application or deployment. So these are some of the advantages. Now configuration management has two main aspects. It helps to bring up the environments quickly from one or more templates. It helps to replicate the environments easily by changing a few parameters. So let me again simplify these 2 points. As I said, it allows you to rapidly apply the changes across multiple servers. So using this tool, we can quickly bring up new environments across multiple servers. So it allows you to start up new environments very quickly. And the second thing is, if you have something in one particular server and you want to replicate the same thing across 50 or 100 or 1000 servers, you can use tools, configuration management tools, Ansible in this case, to do that. So what configurations could we change using Ansible? We could install or set up runtime environment, we could create user accounts, we could change configurations in .conf or .ini files, we could install prerequisite tools. For example, you are going to run a Java application across those 50 servers. So you know Java application would require a JRE or a JDK installed. So who is going to install the JDK in 50 different servers? It's going to be hectic, right? So if you have a tool like Ansible, that would take care of the installations across those n number of servers that you have. So configuration management essentially is managing the config files, but it is not only about the config files, it is managing the prerequisites, the environments, the config files of course, and various tools and libraries that are required to be a part of that particular software package that is to be deployed. So Ansible helps you do all that. Next, we will try to sum up like what are the various options available if we are going to do some configuration management, like what are the different tools that are available in the market to do these tasks. So it's similar to like we have discussed earlier. For example, I have a website to host, so I can either have a Nginx server or I can have a Apache server, and there are other web servers as well, like IIS if you are deploying on a Windows server, and so on. So similarly, for configuration management, there is no single tool that can do everything. We have multiple tools. Now it's your choice, and according to whatever is convenient for you and whatever is more widely practiced across the community, so that you will get help from different forums if something goes wrong, and you will find something in the internet at least. So what are the various tools? Let us just discuss in brief a little bit about them, and then we can weigh in the advantages and disadvantages, and then finally understand why we chose Ansible to do our configuration management tasks. So of course we have Ansible, one of the configuration management tools. We'll come to it in the end. Then we have a configuration management tool called Puppet. This is quite famous as well. So Puppet is a config management tool which is a pull based tool. So config management tools are normally of two types: pull based and push based. So by pull based I mean uh, like you have a configuration management server and you have your n number of servers. Like I was giving you an example of having 50 servers, and you have your configuration management server, which can be a separate server or it can be your laptop, and you want to apply your changes from your system to those 50 servers. So in case of Puppet, you have a daemon running on each of these 50 servers. That's called a Puppet agent, and the Puppet agent connects to the Puppet master, which is your system or a master server which you created for Puppet, and pulls the configuration change from the master and applies it on each of those servers where the agents are running. So these kind of configuration management tools are called uh, pull based configuration management tools. So SSH is another kind of a config management tool, not very powerful, I mean in terms of maintaining the state and stuff like that, but yeah, you can use SSH to log into multiple systems and run commands. So this is a very crucial tool, but it does not have advanced features as Ansible. It would I mean normally need manual intervention, or you would have to write some shell scripts in order to log in via SSH and do the deployments. So if you're working on a modern scenario with thousands of servers, and you have the onus on you to maintain the state of these applications, then I mean SSH would not be a very good configuration management tool. Otherwise, it's a very powerful tool in itself. CF Engine is another tool similar to Puppet. SaltStack is a tool push based similar to Ansible. Chef is a pull based tool similar to Puppet, and it also allows you to I mean apply configuration across multiple servers, and quite famous as well. And Vagrant is a tool for creating images like VirtualBox images and complete deployments. Cobbler is a tool which can be used to manage configuration across normally Linux servers from the Red Hat flavor. So that is also used, I mean, fairly well. RackHD is another similar configuration management tool. Now we come back to Ansible. Now, why we choose Ansible and why is it the most popular configuration management tool nowadays? The reason is this is a push based tool. So the advantage you have using push based tools is you do not have to run an agent on all your servers that you want to work on. So as I said, for tools like Puppet or Chef, you have a agent installed in all the servers where you want to deploy your stuff. So the first step there would be, say you have 50 servers and you want to install Apache, you cannot just go on and communicate with those 50 servers. So what you have to do in that case is you have to have a Puppet agent running in each of your server, and as the server starts up it connects to the Puppet master, so you will have to have a Puppet master also. And in the Puppet master you write your manifest where you explain that you want to install Apache with this configuration file, which you place it in the Puppet master. So all the agents then pull the configuration file and the installation commands and apply it to themselves. So that way all the servers get the same configuration and they maintain the same state. So it works out quite well, but not very flexible because you have to keep having the agent in each of the servers running. Without the agent, the Puppet slaves cannot connect to the Puppet master and they wouldn't know if there is a configuration change. So that's one small disadvantage. While in the case of Ansible, you don't have to have any agents there, it's agentless. So you can run your Ansible scripts or commands or playbooks from any server or even your laptop if you have Ansible installed there, and you can apply it to all your 50 or 100 servers which you have by maintaining an inventory list of all those servers, IP addresses or host names. So it will automatically check like what are the different IP addresses of your inventory list, and from that it will log in using SSH to each of the servers and apply the commands and the configurations. So that way this becomes very simple to use, and even writing the scripts or playbooks for Ansible is very simple. It is written in Python, but that doesn't mean like you will need a programming experience to write Ansible scripts. The syntax is super easy, and there are lots of Ansible roles available over the internet which you can use to do your deployments. We'll talk in detail about that in some time. So let's then move on with some hands-on as well as getting to understand Ansible more. So I have taken extracts from Ansible's official documentation and we'll use them to learn Ansible, because nothing can be better than using the official documentation so that we get whatever is the latest trend in the Ansible world and what are the latest features that have come in, and that will make our learning easy, and it'll make it more relevant than just following random exercises available in the internet. So before we move on, let me just tell you a bit about Ansible. Ansible, as you know, is the configuration management tool. It started up as a community project like we have for any other open source projects, and eventually it was very successful and had a very good adoption rate all over the world in the DevOps community and in the system admin community as well as in the developer community. So as people started talking about Ansible, then Red Hat, which is normally produces a Linux flavor, enterprise Linux flavor called Red Hat Enterprise Linux, was interested in this particular project, and Red Hat acquired Ansible. So Ansible is still open source, but it has a very strong support from Red Hat, being a company, Red Hat company now. And Red Hat also provide a enterprise version of Ansible with a centralized Ansible management tool called Ansible Tower. So that's a separate story, but for now you can know, like, Red Hat is a company which now owns Ansible, but it has still chosen to keep Ansible an open source tool. So we are able to use Ansible free of charge. Alright, so what is Ansible? It's a simple automation language that you can perfectly describe an IT application infrastructure in Ansible playbooks. So in simple words, it is a automation language. Like, you can use Ansible to automate your tasks. So as simple as that. Because with configuration management, we mean automating tasks, isn't it? Like we were discussing, we have a task to install Apache in 50 different servers. Or say the other day we were doing monitoring tools. For example, someone asks you to install net data across 50 or 100 different servers. So would you do that manually? No. You would do that using certain tools or scripts. So Ansible is that tool which will allow you to do this automation. So it's a simple automation language which allows you to write playbooks or ad hoc commands, and you use automation engine that is provided in the Ansible to deploy it all over your n number of servers. Now, what is Ansible Tower? Ansible Tower is an enterprise framework for controlling, securing, and managing your Ansible automation. As I said, like some time ago, I said you can manage Ansible from anywhere. You can even do it from your laptop. Like, you need a system from where you will run the commands on those 50 servers. You would not go to any of those servers, but you would run it from your laptop, or you would create one particular server from where you run those commands across all the servers. So just imagine, like, this server is called the Ansible Tower. So Red Hat has now provided a enterprise framework, like it would have a dashboard and a GUI as well for controlling and securing the Ansible automation. So Ansible Tower is that dashboard or a framework which you can use to deploy your Ansible playbooks across multiple servers. And it also supports APIs, so that you can hit APIs through your scripts or code to trigger certain deployments. So that is a separate story altogether. So today we will be focusing on, like, how to use Ansible instead of focusing on these parts, like about the UI and the RESTful API. We would be focusing on the command line options and the playbooks. So let's move on. So what makes Ansible useful? So three simple words. We discussed this a bit before as well, but let me reiterate. One is, it's simple. The Ansible code, if you go through it, is syntactically very simple to understand, and you would not need any special coding skills in order to write Ansible playbooks. Then the tasks are executed top down, that is in order, so it will be very easy to read the Ansible programs. So you start reading from the top to the bottom like you read a page of a book. Next advantage is very powerful. Like it allows you to deploy applications, it allows you to change configurations, it allows you to orchestrate workflows, and so on. By app deployment, an example can be you want to deploy net data monitoring tool across 100 servers. So Ansible can do that. You want to change Apache config file, or you want to change your IP address of a Linux system, or you want to change a certain port number from a config file, or you want to change or create a database on a MySQL server. So anything related to configuration management can be done using Ansible. Then it also allows you to orchestrate workflows. What does that mean? For example, I have an application which comprises of a front end and a back end. Now the back end has a MySQL database and the front end has a, say, PHP website. Now I want to install this particular application on 100 different servers. So I have a sequence of operations here. Like for example, I'll have to have the database packages installed first, and then I have to create a database schema. Then I have to import my database tables into that schema, and only then I can install Apache and put my code on the var www.html folder where you have the Apache code, and then I would like to connect my code to the database. So it has to be done exactly in this sequence. If I do not follow this sequence, then my application is going to fail. So because for example, if I put the code first and I do not have a database created, the code would throw error that unable to connect to database or something like that. So if I have a sequence of operations to be done, so I have to orchestrate this sequence so that it happens like 1 2 da da da, so it goes on like that. So how do I orchestrate this sequence? So in order to do that, we can use the workflow orchestration feature. Like for example, you write your Ansible playbooks in such a manner that it does task A first, and only then if A succeeds it moves on to do task B, because it has to be done in that way and not in any other order. So it allows you to do these kind of things as well. Apart from that, it's agentless. We spoke about Ansible's difference with tools like Puppet or Chef. So the main difference there was Ansible doesn't have any agent, while Puppet Chef have agents installed in all the servers which you want to manage. So that gives Ansible an edge over other configuration management tools, because you do not have to have anything there. Like you do not have to put any agent or anything. You just have to know the IP address of those servers, and you should have a authenticated user so that you are able to connect to that server. Like you should have a SSH user in place that allows you to connect to that server and deploy stuff. So that makes it a very convenient configuration management and orchestration tool to operate, because you do not have any agents. So you just maintain your inventory file with the list of IP addresses of your servers, and you have your SSH keys and stuff like that, which you use to log into the servers by setting up a SSH connection and then deploy your stuff there. Okay, one more thing I would like you to remember is, how does Ansible connect to various servers? It uses the OpenSSH protocol. This is a interview question, you can say. Like people ask, how do Ansible connect to the different servers? So Ansible uses OpenSSH normally if you are using a Linux server. If you are using a Windows server, then it would use WinRM. Okay, so these are two different protocols that are used by Ansible to connect to the endpoints. Now, how does Ansible work? This diagram just simplifies things for you, and then when we do it practically, you would it would clarify everything for you, like what's going on and how it's working. So first of all, how Ansible works, we'll look at that. So Ansible, you have a local machine, say your laptop or a server which you have assigned to have your Ansible stuff working on. Like uh, you would install Ansible clients here and try to push your code from this node to the other nodes. Now these are the n number of servers you have. Like I was talking about 50 servers where you want to deploy Apache. So these are those nodes. So here in this diagram there are three different nodes where you have to deploy something, and this node is the node from where you will apply that code. So it would be your laptop, or it could be any one server which you have dedicated for this purpose. So this master node would have the configs ready and the playbooks ready, or you would run the ad hoc commands from this particular master. So here if you write yum install apache 2 to install Apache, so this command would be propagated to all these nodes, and if the command runs successfully, so all the nodes will have Apache installed in them. Similarly, if there is a long sequence of tasks to be done, you can write playbooks. Okay, so playbooks would be a story that has to be applied to all these servers. For example, you want to install Apache, you want to open up a port in that server, you want to install a database, you want to start up all these services, and you have to set up a firewall or some security rules. Say you have all these tasks to do. So it would be hectic again if you write all these commands from the main node and apply it to all the nodes one by one. So in those cases when we want to simplify our tasks, so in those cases we use Ansible playbooks. So we write all these sequence of commands in a particular syntax in a playbook, and once that playbook is ready, we create an inventory. Inventory is nothing but a list of IP addresses or host names of the servers. Like the inventory file will have the IP addresses of node 1, node 2 and node 3 in this list. So when you apply a playbook to an inventory list, so then the Ansible client, what it does, it goes and logs into each of the servers from that inventory list and runs that playbook there. So based on the outcome, it publishes the outcome, like what happened when all the commands in the playbooks were applied to different Ansible, endpoints. So that is how Ansible works. So it uses a playbook which has a set of commands. It uses an inventory which is a list of different IP addresses or host names of your endpoints. And when the Ansible ad hoc command or the playbook is run, then it applies the contents of the playbook to all the servers. So whatever instructions are given in the playbook, those commands are run into these nodes, and all these nodes come into sync after this is deployed. By sync I mean, say you intend to install Apache in 3 servers, so after a while Apache would be installed in all these 3 servers. So that way they come into sync in terms of their configurations, in terms of their applications installed and so on. So they are all uniform and would behave similarly when when we start using them. So now we'll go on and move on to install Apache, and these are the commands which we would use to install Apache. But before that, let's set up our lab so that we can start learning and installing Ansible and learning more about Ansible. So here I would like to show you a couple of things. One is, you would go into this tutorial page where I write the notes. So here you would have a very a better understanding of Ansible, because I have elaborated like what Ansible is, what how Ansible works, whatever we spoke about so far. So that has been elaborated here. So go through it, like what Ansible is and how automation and orchestration is done using Ansible and so on. What is the need of using Ansible? Like what advantages does it provide? A little bit about the history of Ansible and how Red Hat took over Ansible and so on. And then we have some jargons, Ansible related jargons. So we'll come to this once we install Ansible and start reading more about playbooks, and then we'll try out certain tasks. Okay. And what I was thinking is we'll try out these tasks on number one, we'll create some nodes in AWS, so that will allow us to use the AWS servers and learn how to create EC2 nodes. So that would give you some exposure, and then you can try creating your own Amazon accounts and try this out. So that is one thing. Second thing is you will also learn like how I connect to different Amazon nodes using SSH keys. So for those who are used to with cloud and Linux, that's a cakewalk for you. Those who are not, you can just go through like how I'm doing it and follow it. So these are the two things we'll do. And apart from that, before we start creating the instances, I would like to show you like what would be our lab working setup, so that you understand what is going on when I'm trying to do the hands-on exercises. So let me show you what I want to set up when I'm actually doing the installation. So let me see if I can draw something for you. Okay, let's try this one. So for example, this is one server which we create, and it's the Ansible master node. So I write M here, and we will create two different endpoints. Okay, these are also two different servers. So it can be node 1 and node number 2. So what we'll do, we'll create one instance in AWS cloud, that is the master node. We'll install Ansible here, and these are the two nodes where we will deploy our applications. So and node 1 and node 2. So from the master we'll run various commands on node 1 and node 2 together. Okay, so if you can run it on two nodes, you can run it on n number of nodes later on. Like if I have a node n, so this is the nth node, so you can run your installation, like run your playbooks or your commands to n number of nodes. Okay, it's not only running it on two nodes, you can run it on any number of nodes. All right, so in our setup now, what we'll do, we'll just run it for two nodes. Like we'll have a master node n1 and n2, so we'll run our playbooks and commands to these nodes. Okay, so that way it will demonstrate how to run. So we'll need 3 servers to be created on AWS. So let's do that. So here we are logged into the Amazon console, and we are in the North Virginia US East 1 region. So AWS has various regions distributed all over the world, so you can choose any region where your company wants the app to be hosted. So we are choosing just the default US East 1 region, that's the most popular one. And our goal is to launch 3 instances here. So once I do that, you will be able to see how to launch new instances. And as we always have been using Ubuntu for all our exercises. We'll continue doing that. You can choose any other Linux flavor as well, but since we are using Ubuntu for all other sessions, so let's continue with that, so that there is homogeneity in whatever we are doing. Apart from that, we will have our playbooks which have commands, mostly that will work for Ubuntu and Debian based systems, so that will help. So let's launch our instances. So it's simply you have to click here or here to launch a new instance, or you can go to EC2 and that brings you to this page where I was, and from there you can again go on and launch the instance. So once we click on launch instance, it gives you a wizard where you have to choose which instance to launch and how to go about starting those instances. So the first thing you have to check is to choose the AMI or the Amazon machine image. So that allows you to define which operating system you have to use in order to launch your instances. So since this is a demo account, and as I told you, Amazon gives you a free tier for 1 year, so you can use this free tier option so that you do not run into any risks of getting charged. So I just check this box just to ensure that I'm only using the free tier images and the free tier instance. And as for the operating system, we would be using Ubuntu 18 as we had been doing for other exercises. So you have to select this option. When you want to have the Red Hat Linux, you can choose this one, or Amazon Linux. It also belongs to the Red Hat and CentOS family, so you have to choose this, and so on. There are other custom images also, so we'll talk about that in some other session when we discuss more on how to work on Amazon cloud. So let's go ahead and choose the Ubuntu instance. Now all these are different flavors of the instance types, so depends upon the flavor type, depends upon how much virtual CPUs or how much memories are provided or how much disk is allocated. So since we are using the free tier, we would be using this one, T2 micro instance, and configure instance details. Move on to the next step. Number of instances. We would need 3 instances. One would be the Ansible master and the other 2 would be the host systems. So I make it 3 so that we launch 3 instances together and save time. This is for a spot instance, we don't need that. Let the rest of the things be at default in this screen. We are not discussing about VPCs and other stuff. That is for another day. And click on next and you move on to the storage option. Now here you can increase the disk or keep it at 8. So let's make it 10 so that it's uniformly distributed, like rounded off. So we have 10 gigs hard disk in each of the servers which we are going to provision. And as you can see here, for free tier customers, they provide 30 gigs of EBS storage, which is free. So that's fine, we are using 10. So we move on to the next step, adding tags. So here you can add tags so that you can define your instance. For example, this is a production environment. You can write a key env and a value called prod. This is just an identifier so that you identify your instances with the tags. You can name it anything, like you can put another tag where you can write role and here you write Ansible. So the instance gets a tag that this instance is meant to run Ansible scripts. So this is at your discretion. Then move on. Here's the definition for the security group. You can use the default security group and move on, or you can add a new security group. So just in case we do that, we can name something like this, say DevOps security group in short. And this is a description we'll write, like it's a security group for Ansible demo. So that's what we are going to do. So now here you define which ports to open so that your servers would be publicly accessible, and what are the ports you need to open in to ensure that your server is just secure and you're not exposing too many ports. So 22 will need this port in order to SSH into the server, and we already discussed Ansible uses SSH to run the commands, so we would need this. And apart from that, since we are going to run one of the playbooks which involves having port 80 open, so let's allow the HTTP traffic on port 80. And if you want to install net data to do the monitoring part, and you want to install net data with Ansible, then you would have to expose the net data port. So net data port is not available here as a default port, so you can do one thing. You can write custom TCP, and here we know the net data port is this 19999. So we put that port and just copy that and put it here, that it would be available for everyone. So 0.0.0.0/0 means any traffic coming from any source in the network. So you just remember this one, and when you read more about networking fundamentals, you would know like why this address is called the broadcast address. Like it is for pardon me, it's a multicast address, like it belongs to everyone. So this is it, we are done. So we review and launch. So it says like we are opening certain ports, but we know which ports we are opening, and we are going to open these ports to the world and launch our instances. Now comes this pop-up which says do you want to create a key pair? So I choose this option, create a new key pair, and we can name it DevOps demo 01, just to make it unique. Okay, so we have this key pair. Now why this key pair is required? This is required to log into the system. Like Amazon or any other cloud provider does not allow you to have a password based authentication. So all of these are password less. So in order to run a password less authentication, like when you need to SSH into the server, you would need to provide a key. So I'll show you how we will use the key in order to log into the server. So first thing, you name the key, download the key pair. So it would result in downloading a PEM file, and then you would use that to SSH. So it would be better if you try this from a Mac or a Linux based system, but if you do it from Ubuntu, this step would be a bit different. Like you will have to convert this .pem file of the certificate into a .ppk file, because putty will be used to SSH into the server in that case. We can discuss that offline later on, like once we are through this exercise. So this part is done. I have my keys downloaded in my system. So now I can go ahead and launch the instances. So this will now create 3 servers. You can see these are server IDs which are getting created. So we can click on view instances to see what is the status. So now you can see these are in pending state, which means the servers are getting provisioned, like they're getting created. And as you can see, all of them are T2 micro instances and running on US East 1E. So these are all free tier instances. So while these are coming up, we can just name these instances so that we do not confuse them. So this is going to be the Ansible master. Like this is the node from where you will run your Ansible commands. And this is say host 1, and this third node is host 2. So what we are going to do, we'll install Ansible on this node, and we'll make this node the master, so that we'll have the keys and everything on this node, so that this node can log into this and this node without a password. So that would make the master reachable to all the hosts. And then we will apply our scripts, Ansible scripts and commands from this node, so that it gets deployed on both the nodes together. So that will demonstrate like now, as you have host 1 and host 2, if you have 50 or 100 hosts like host 1 and host 2, you will be able to do the same thing on that 50 hosts together. So how do we start off? So the first thing we have to do is go into the Ansible master. Mostly we wouldn't even have to log into these hosts other than just logging in to verify or check something. But the master host needs our attention, like we will have to log in there, install Ansible and other packages. So let's get started then. So how to connect to this host? If you do a right click and click on connect, you will find some guidelines. Here it says like you have your private key file downloaded, so we already did that here. It would be in our downloads folder, and the first command we have to do is run a chmod 400 on that key. So that gives a very restrictive permission, and it's for the security reasons that we do this command. So we go to the terminal, we enter the downloads folder, because I have downloaded that particular key there, and then run this command. Alright, so now once this step is done, we would be able to log into the instance using this command. So as you can see, this command is using the key for the authentication. This is the username for the Ubuntu servers. The username is Ubuntu, and this is the fully defined domain name, FQDN, for that server. And I say yes, that I want to connect, and I am inside that system. So now we are inside the master server. Which one? This one. In order to validate, you can check these details. Here you can see this is the IP address of the private IP address of the Ansible master server, and if you check here, you will see the same IP address, right? 172.31.56.81, and here we are, it's the same server. So we have logged into the correct server. Now let's begin our exercise of installing Ansible. As you can see in this slide, like the first step would be to install Ansible on the master server, so that we can run the Ansible scripts and playbooks to the other servers to provision something or to manage configuration and so on. So how do we go about doing that? So it begins with installing Ansible. So again, you have this learning notes page in our repository. So I have created a learning notes page for Ansible as well. So you can read more on what are the definitions of Ansible, why we use them, and so on. There are some terms about Ansible which I would be discussing very soon. So now let's focus on installing that package, Ansible package on our Ansible server. So here are two ways to do that. One is for CentOS Red Hat systems, you have to run these commands, but we are not doing that. We are doing it on a Ubuntu server, so we have to run these commands instead. So step one is to do a sudo apt update. That is pretty common, so that you are sure that all your commands are updated. So we do that, and once the apt update completes, we'll install these common packages. These are dependencies for Ansible and Python. So running this ensures that Ansible would get installed and work properly. So we copy this command as well and wait for the installation to finish. Here it has. So let me clear the screen again and run this command. So it's also installed now. Then we move on to adding the Ansible repository. This is where Ansible binaries exist. So adding these repositories here ensure that your Ansible is picked up from the official repository and it works fine. So it's asking me to press enter in order to add the repository here. So I did that. And once the repo is installed, we'll go ahead and run the actual command that would install Ansible. Before we do that, we are updating it again because we added a new repo, and then we move on to install Ansible. Alright, then it asks for validation whether we want to proceed installing Ansible or not. We say yes, and the installation begins. So this is pretty simple. Like Ansible installation is pretty simple. You just have to keep those commands somewhere or follow this learning notes, and then once Ansible is installed, you will be able to do a lot of activities using Ansible. The top activity is being able to install something over multiple servers at the same time. Like we were discussing, for example, you have 50 servers and you want to install net data for monitoring to all those 50 servers together. So if you do it manually, you have to go to those 50 servers SSH and log in and install the same thing 50 times. But here you can do it at one go. So now we do not have 50 servers, we have two servers, host 1 and host 2. So we'll try it on two servers together. So if that works, that means it can work on 200 servers also. So that's the proof of concept we are trying to demo here. Alright, so Ansible installation is done. And clearing the screen once again. So now that Ansible has been installed, it means that Ansible commands should run and work properly. Okay, but for Ansible commands to run and work properly, Ansible should be able to reach all the nodes that are available in your cluster. Now we have two nodes available in our cluster. What are they? Host 1 and host 2. So how do we reach host 1 and host 2? In order to reach host 1 and host 2, we should have our SSH keys available. What was the SSH key for all these hosts? It was this key, the key which we downloaded, DevOps demo 01, right? So let's place this key in the Ansible master server so that using that key, the master can be able to connect to host 1 and host 2 and do its installation activities. So the first task would be to ensure the connectivity and have the key in place. All right, after installation of Ansible, of course. So we have Ansible installed. Now next step is to ensure connectivity, and third step would be to have the keys there so that the login is possible from the master to the hosts. And then we will move on to do the deployments using Ansible. So how do we check connectivity? It can be done by a ping test, but we can do the ping test after adding the key. So let me go ahead and add the key then. Opening another terminal. The key was in the downloads directory in my system. So I go to downloads and the key name is DevOps demo, right? So we have to run this command cat DevOps demo01.pem. So that shows the content of the key. Okay, so why I'm doing this, I'll copy the content of the key and place it on the Ansible master server. So that will allow that master to be able to connect to both these slave systems or the host systems where we want to deploy. So what we are doing here is copying this content of the DevOps demo01.pem and we are storing it as a file with the same name, or you can name it anything, like this is just a key file. So I opened a blank file and put the contents of the PEM file here and saved it. Now we have to provide a permission like we did when we downloaded this key file. So chmod 400 and this. So that gives the permission to that key file. Now we will have to import this key file into the SSH agent. So these are all the steps. So once you're watching the video and doing it with me, this will work perfectly fine for you. So what we have to do now is to add this key to the SSH agent. All right. So in order to add the key to the SSH agent, we have to run this command. Okay, so it's as simple as that, eval SSH agent. So in order to add this key to the SSH agent, you will have to first launch the SSH agent on this server. So we do that by running this command called eval SSH agent. So that will allow you to add the SSH agent here. And once that is done, you will be able to add the key. So how do we add the key now? SSH add and the name of the key. So once this is done, we know that our agent will be able to connect to the other two servers, but we haven't verified this yet. All right. Now, as you can see, these are the steps which were done manually, and this is a one-time task. You can even put this into a shell script and run it. But in order to understand what was done in the first time the Ansible server was set up, it is very important to know these steps, because without connectivity, Ansible would not be able to deploy stuff on different host servers. All right, so we are done now. Let's check the connectivity part. So for that, here is a command where it says Ansible -i hosts and then all and m ping. So what does this mean? Now this command means Ansible is of course the Ansible command which is doing the stuff. -i means the inventory file name is hosts, and whatever hosts are there inside that file, try to ping all of them. So this is what this command translates to in plain English. So we have to create a file called hosts, which would be an inventory file for Ansible. All right, so let me create a host file here, and the host file syntax is like this. You can group it into a number of you can group it into a name. So I say these are demo hosts. All right, so we are doing a demo and these are the demo hosts. What is the address of these demo hosts? We can get it from the AWS dashboard. Host 1 has a address of this. It's good to take private IP addresses so that there would be connectivity between these instances without going through the external internet. So I take the private IP address of the host 1 and put it inside the host file, and on the next line I take the private IP address of the host 2 and put it in this file. So once this file is saved, we are all good to start our ping test. So going back to this command, let's try to ping all the hosts which are present in the host inventory file. So this one comes only in the first time you're trying to do it, because these host names haven't been added, so we have to just say yes. Okay, so one of them was reachable and one wasn't, so we can try the same thing again and see. All right, so we accepted both of them with yes, so now both of them are green, which means both of them are being able to be pinged, or both of them are available. Now if I clear the screen and run the same command again, now we see the connectivity is there and working fine with both. So here you can see like this is the IP address it tried to reach. It was able to reach it, so it's a success. And Ansible uses these libraries, Python libraries, under the hood. So this is what the interpreter was, and with the ping command it received a pong command from the host, so which means the host replied to it. The same thing happened with the second host as well. So this is what is explained here, and here I have explained like all the terms related to it, like this number 1 is the status of the command. So in Ansible this is called the status. This is the host, like inventory here parameter, which points to the host file. Then the host on which the command ran, that is this one. In our case it was the IP address. It can be the host name also. And this is the command which we ran. So if you run ls, then it will do a ls command on those two servers. If you run the IPA, so it will display the IP address of those two servers, and so on. So it's just straightforward, like whatever you run there, you get your response that way. Okay, so this part is done. We have installed Ansible and we have used Ansible to check the connectivity between these two nodes, and now the connection is established. Now we can move forward and do greater things with Ansible. So let's move on to that phase. So with Ansible, we can operate it in two ways. One of them is using Ansible ad hoc commands, and the other way is using Ansible playbooks. Okay, so we would be focusing on these two aspects of Ansible, and I'll also tell you when to use which way of working with Ansible. Okay, so if you are doing a one-off activity, you can use the Ansible ad hoc commands. For example, someone asked you to restart a service across 50 servers, or to check the IP address of those 50 servers, and so on. So in those cases, you can just use an ad hoc command. Okay, but if you are asked to do a complete workflow or a configuration management change, like for example, someone asked you to install many packages. For example, uh, there's a travel website, and that travel website is ready, and someone asked you to create an environment in production that would be over 50 different servers, and deploy that travel website on 50 different servers. Now when you analyze, you find that uh, in order to host that website, you will have to host Nginx or Apache on those 50 servers. That website also uses databases, so you have to install MySQL database on all those servers, and you have to set up the username password of MySQL, and then import the database dump into that database server, do the connectivity with the code, and then move on to deploy the website and see whether the website is working or not. So when there is a complex set of instructions that has to be carried out and not just one command, then you cannot use a ad hoc command option of Ansible. Then you will have to go with the playbook option. So these are the scenarios when you use playbook or not use a playbook. Okay, so now it will again not seem very coherent to you, but let's start doing that, and then you will again recap and understand what I am talking about. So ad hoc commands are for doing one of things, like we just did a ping to check whether all of them are fine or not. We are not doing a second step here. So then you can use ad hoc command. Okay, here are some examples of ad hoc commands. You can go through these examples. I'll demonstrate some of them, like okay, let me demonstrate a copy, and I'll demonstrate some installations also. All right, here I have some examples for you. I think I put it here. Let me just cross check, otherwise we can update our notes and commit it, so that you will be able to do these things on your own by following the notes even when I'm not there. So I was just checking if we have some sample ad hoc commands here or not. If not, then I'll put it across for you, no problems. This command is there, which we already did. Okay, this is a copy command which we can try, and I'll show you some more ad hoc commands and you can note it down as well. All right, so let me first write this command out in your Ansible server, and then I'll explain you what it is. Okay, now for example, I want to copy a file from this computer, like this Ansible master node, to both the servers on a particular location. So how do I do that? Okay, so this command allows you to do that. So I'm not running this command, I'm just canceling it, because we have to do a certain thing before we move on to do this copy. So for example, where are we located now? We are at home Ubuntu. So let's create a test file, and inside I'll just write test and save this file. Okay, in order to create a blank file, you can also do like this: touch test01. Say we have a file called test01.txt. If I do a touch also, I will be able to create a blank file. So here you see there is a test01.txt, and this is the test file which we created. So if you use the touch command, you will create a 0-byte file, like blank file. You can go on inside it and write anything you want there and save it. So you can use either of these ways to create a file. So we have a file called test file, and we want that file to be copied to /tmp/test file location on both those servers, like this one and in this one. Like we'll have to log in these two servers, and then I'll show you. Like just imagine that these three tabs are for the three servers which we created, and we are copying this to both the servers. So how will this skill be handy? For example, I was talking about Ansible being able to do a configuration management, right? So for example, if you have an Apache server and you have a config file for Apache at etc httpd.conf, or you are installing MySQL and you have a ini file for MySQL at etc my.conf, and so on. So there are certain parameters inside those configuration files, and you might want to change them and apply it across all those 50-100 servers which you have. So doing it manually is not a good practice. So in those cases, you can use this copy ad hoc command to copy that file to that destination where you want across all the servers. So this is a similar scenario. So we have a test file and we want to copy it to two of those servers, and then we'll manually log into both those servers and see whether that file got copied there or not. So in order to verify that the file isn't there already, just in case you want to see whether that file is there or not, we can just log into these servers. Okay, we can directly use the command provided by AWS. That would be faster. Connect and I'm copying this one, and I'll have to go to the downloads directory because the key is there, and I log into the second server, that is host 1, and let me similarly log into the third server, that is host 2. So it's easy to copy the command from here because it provides you the correct IP and the key name and everything, so you don't have to write anything there. Only thing, you have to put yourself in a place where the key is available. So it's in downloads folder in my case, so I am entering the downloads folder and doing this. So here we are logged in to the second and the third server. So now if we go to the /temp of this server and do a ls, we don't see any file called temp file. Let's do the same thing on this server as well. So we don't see any file called the test file, right? So if I run this command now, it will copy home Ubuntu test file to this location /temp. So in that case, if the copy command works fine, then we will have this file on the temp location in both those servers. So you saw the command has concluded. Now let's do a ls again here, and now here you go, you see a test file here and a test file here as well. So at once you could add the file in two different servers together. So if there were 200 servers here, it would have been the same case. So you could have copied the config file or anything which you want to move to 4, 5, 50, 100 servers together. You can do that. So this is a very powerful tool that allows us to manage multiple servers together. In earlier days, when the system admins did not have anything other than SSH to log into servers, and they were not too much into shell scripting or automation, then it would be a tedious and hectic task to do everything manually across the number of servers. So that is a ad hoc command, like you're doing one particular function at a time and you're not doing a very complex operation. Now let me explain a bit on what comprises this ad hoc command here in this example. So this is the Ansible client, like the Ansible command. -I have already explained, it's the inventory switch, and then you name the inventory file inside which you have the IP address of those host systems. So if you have 50 servers which you want to manage using Ansible, you have to have the IP address of those 50 servers in that host file. Now we have two, so we have two IP addresses in the host file, right? So that is the host file which contains the inventory list, the list of IP addresses or host names of all the servers which you want to manage. This all switch says like you want to deploy to all of them. Like here you can also do some selective deployments. Like if I create another group and I call it host 1 and just place one IP on that host 1 and leave the other one alone, and when I deploy, if I write Ansible -i hosts and here I write host 1, then in that case it will only deploy it to one of the hosts and not all of them. So this defines like whether for all or for a particular one, so you can define it here. -m stands for module. So what module of Ansible are we using? So if it is like there are multiple modules of Ansible. For example, now we were doing a copy, so we use a copy module. So for example, if you want to install something and you are on a Ubuntu system, you can write apt here. So the module name will be apt, and inside this double quotes you can write the name of the application that you want to install. So that's how Ansible ad hoc commands and modules work. In this case we were doing a copy, so according to syntax we mention the copy here. This is the username. Become root means you get the sudo powers once you log in as that particular user. So we log in as Ubuntu, then we get a sudo power in order to run our application. And then this defines like what is the source and the destination, because a copy command was involved here. So you need a source file and a destination path where you have to paste that file. So this is about this particular command. Now I can modify this command to do certain other operations also, and demonstrate what more can ad hoc commands do. Now this is a very important one. Like you can use a module called shell and run any command you want. So it will run on all those servers. For example, I want to see the IP address of both the servers, or I want to know the host names of both the servers, and also I want to see the IP of both the servers. So I put both the commands here and put the shell option here and press enter. So it ran on both the servers and provided me the host name here and the IP address, the output of the IPA command. Then again it went on to the second server and did the same thing. So you can run any command actually. Even you can run installations using the shell module if you do not want to use the apt there. For example, you can do like this: apt install ntp, or any package you want to install. Or for example, if you're installing Docker, you can write docker.io and it will install Docker on both the systems. But yeah, you have to put the interactive switches. Like you don't want to make this thing interactive because it will run on a headless mode. For example, Ansible will go on and try to install Docker, and if it asks a question like, do you want to proceed, yes or no, then Ansible won't be able to provide that yes, because so in that case you always have to provide an answer before. Like for example, apt install docker -y, that would install Docker and say yes whenever there is a prompt. So this is how you can use your knowledge of Ansible ad hoc commands to actually do anything over multiple servers. But this process has some disadvantages. What are they? Like if it is a complex process, as I said, if someone wants to host a travel website across 50 servers, so you have to first set up Apache or Nginx and then open up the port, then make some changes on the config, take the code from GitHub and put it on the Apache root directory, and then restart the Apache service. Then that is one part done. Then you have to move on to the database if it is a dynamic website and uses a database. Then install MySQL there on the server, again make it listen to a certain port, tell the application that database is here and listening on this particular port. Then you have to create your database users, passwords, uh, I mean import the databases into that and get it connected to the front end and so on. So when there are lots of sequence of events that is going to happen, so you cannot write those 10-15 sequences here using ad hoc commands and move on. So in those cases ad hoc commands are not very effective. So then we write playbooks. Playbooks are nothing but orchestrations written using Ansible, and that can be used to create the entire workflow or the desired task which we are about to do. So we spoke about modules, like we use the copy module, app module, and so on. So there are lots of other modules. Let me show you, like if you want some further learning, you can always follow the Ansible, this one. official documentation that contains all the modules, because the one here is not an exhaustive list. There are lots of modules. So you can see cloud modules, clustering modules, commands, files, and so on. So if you go to cloud modules, you see there are lots of names and so on. So when you're into advanced levels of Ansible, writing playbooks and all, so these documentations will come friendly. So better know like this one exists. But normally for doing any task, you would find ready-made Ansible playbooks in the GitHub. Okay, many people have contributed. So you normally wouldn't have to write something from scratch. You would use someone's playbook and improve it or modify it to work for you. Okay, so that is how it works. And also there is something called Ansible roles, and there is something called Ansible Galaxy, which can be used to deploy Ansible's playbooks. So we'll talk about that in a while. So let's first see how a playbook looks like, what can it do, how is it better than ad hoc commands, and then once we reach that point where we know what a playbook is, we'll discuss about Ansible Galaxy and Ansible roles and all that stuff. So first let's see how a playbook works, and once the playbook works fine for us, then we'll discuss about its technicalities. Like there are various parts or attributes which comprise a playbook. Okay, these are certain terms which we already discussed, like what is the inventory, how does it look like, how it is grouped, and so on. And this is about modules and what are the different types of modules. Okay, so we'll go through that when we do the playbooks and ad hoc commands. I mean more on them. So let me take you back to the notes page. Alright, so these are the stuff you know. Yeah, this is one important thing. Go through the notes actually, like even when something is not covered here in this lecture, you can go through the notes and learn about it. For example, this one caught my eye. This is a very useful command. Like if I do a ping, for example, I'm doing a ping, it could be any other command also, and I do it like this, then it goes to both the nodes and does the ping. Okay, now if you want to run it just for one node, so then you have a switch called limit. Okay, you can use that switch to limit the run on one particular server. For example, I want to run it only on 49.0, not on the 48.61 server. So I can write like this, and it will just run on that particular server instead of running on both the servers. So that way you can also selectively install. For example, you have 50 servers. Out of that, only 5 servers will require net data monitoring, rest you don't. So in that case, you can either do one thing, you can group those 5 IPs under a certain name and use the inventory file to group it, or you can limit the run to those servers by using the limit switch. Okay, so play around with these things and try to learn it. So that was about the ad hoc commands. We will now focus more on the playbooks and what playbooks are, how they are organized, and how they work. And then we'll do a demo with a playbook which will set up a travel website, which we were discussing about. So we'll come to that in a while. So first of all, what is a playbook? And then we will go back to these terms which I said we'll discuss later on, important terms used in Ansible. So that will make things clear for you when you go back and learn these notes. Okay, So now let's go to the playbook part, and then we discuss Ansible roles, and then we discuss the various jargon around Ansible. So in comparison to ad hoc commands, now you know what ad hoc commands are. They are just single line commands which you can do using Ansible to do simple tasks across multiple servers. So in comparison to ad hoc commands, playbooks are used in complex scenarios. They offer increased flexibility. We discussed that. Playbooks use YAML format. This is very important. Like people ask this in interview questions, like what language Ansible is written on. You will say Python. And how Ansible playbooks are formatted. They're formatted using YAML. YAML is a format which stands for yet another markup language. So there are lots of markup languages actually. For example, any website is written on HTML, so hypertext markup language. Similarly, we write these readme files. You might have seen when you are creating a repository, writing a readme file, it has an extension readme.md. So that is a markdown format. Similarly, these Ansible playbooks have a YAML format. Okay, so YAML format looks something like this. So you have indented text, like hosts and tasks should be on the same line. Then something that goes under this module would be having a tab difference and then defined here, and so on. So it is like a cascading way to define your stuff, so that you know what is under which task and what module lies under that task and what are the names and state and so on. So we'll discuss each of these parts and understand what a playbook looks like and what are the various components there. So it's all explained here, so you can just go through this one in more detail. For now, let me explain this particular simple playbook. Okay, and when we do the other complex playbook as a part of this demo, then you will have some more clarity there. So a playbook is just a file, YAML file, which will look something like this, and there would be multiple files involved in a playbook repository, and there can be just one file also. Okay, so if you just save this one file, it will also work and do a certain task. But if you have more complicated tasks, you can have playbooks which look like this also. Like it will have multiple files, folders, roles, and inside it there would be some more playbooks and so on. Okay, so these are a bit complicated versions of playbook, but this is a simple playbook. But don't worry, like all of them will look alike if you go inside the files. For example, if I go to this one, I see the same thing what I see on the others. Okay, so coming back here, this is how a playbook looks like. Now this part 1 is a group of hosts on which the playbook will run on. So if I write hosts and here I write group 1, so it will run that playbook on those particular groups. For example, in our case, let's have a look at our host file. So we have grouped these two hosts under a group which we call demo hosts, right? So this group 1 is similar to what, like it's the same as what demo hosts is. Like for example, if we want to deploy this playbook to our system of 2 servers, then we would write hosts and then demo hosts, so that would install it on those 2 IP addresses. Then comes here are the tasks. So tasks are the self-explanatory, like what is the playbook supposed to do, so that will come under the tasks. So now each task will have a name. So this name can be anything, like you just define the task. This is for human readable part, like for people to understand what the task is. So install this XYZ package, and what will be the module to install. So here they have used the yum module. So it looks like this playbook is designed for a Red Hat or CentOS Linux. So if it is a Ubuntu, we would use a apt here, and then the name of the package, and the state will be the latest. For example, that means whenever you install it, look for the latest package in the repo. So that is what is being explained here. And then once the installation is done, also check the service state. And now this service module is used to check if the service is up and running. So what will be the state? It should be started. So these are the desirable states and commands which we are mentioning in a playbook, so that when the playbook is run, then it will do that desired set of tasks which it has been asked for. Okay, when I run this, when I run a playbook, this will make more sense to you. Okay, so for now you just understand a playbook is a YAML file. It contains different directives like hosts, tasks, and modules, and then whatever is defined under that thing is executed on the target hosts. Okay, and Ansible also retains the state of a particular service. For example, if you define that the service should always be on a start state, then it will always ensure that the service is started. If it is stopped, it will start that service on that particular server. So that is it. Then this is a demonstration of how you can group your hosts. Like for example, the simplest way is to do like this: put a group name under square brackets and put the IPs here, and then save it in a file called host file, or whatever inventory file name you want to put. And here there is some more elaboration here, like for example, if you want to put a port number of SSH also in your inventory file, you can do that in this format, and so on. So you might be thinking, why to do that? By default, the port doesn't need to be put here if the port is 22, which is the default SSH port. So you don't need to do anything, because by default it goes to 22. But just in case your server has SSH configured on a different port, then you will need the port to be defined in the host file. So you will need to add Ansible underscore SSH underscore port is equal to whatever custom port number you have. Okay, but if it is 22, no need to put that there. It will work out of the box. So this is also another example of a playbook where the playbook is running on group 1 hosts, and the task is to enable SC Linux, and the family is Debian, so which means this playbook is written for Ubuntu family. So Debian and Ubuntu belong to the same family, so this playbook would be able to run in this particular system. Okay, so this is it about simple playbooks. Then we'll move on to understand more about the playbooks and do stuff. Okay, here it gives a definition of what a role is and how the playbooks look like. So I'll explain a bit to you, and then we'll run some playbooks and do this stuff. Okay, so before we understand and start running playbooks, let's now go through these terms. So you might be thinking, like, I had these terms in the top of the page and then I went on till the bottom and then come back here. That is because now it will make sense to you. What is the Ansible server? A machine where Ansible is installed and from which all the tasks and playbook can be run. So now you know what it is. This server, the master server, is the Ansible server. This one. Because this is where the playbooks and Ansible command is installed, and from here we will run the tasks that is to be deployed on all the other servers which we have in the inventory. So that is clear what an Ansible server is. Then we move on to the module. What is a module? Module is a command or set of similar commands meant to be executed on the client side. For example, you were doing a copy. So copy is a module that is to be executed on the client side. By client side we mean the host nodes, okay, or the target nodes. You can call it by any name. And then comes the task. Task is a section that consists of a single procedure to be completed. Okay, so as we saw in a playbook, you can go through any playbook and you'll find that. For example, if I go through this, no, this is not a very elaborate one. Okay, this one is much better. So you know what a host is. Tasks means what are the different modules are to be called and what are the different commands or stuff that has to be run. So that is defined under tasks. For example, this task involves make sure that the remote app root exists. So it checks whether a particular folder exists or not. So it uses a file module and checks whether this folder exists or not, and if it is, then whether it has this permission set or not, owner and group names are perfectly defined or not, and so on. So that is task, like it defines what are the tasks that is expected out of that playbook. Role, way of organizing tasks related to files later called in the playbooks. This is very important, like to understand the meaning of a role, because this will help you a lot when working on complex playbooks. So let me show you what a role is. For example, this repo is a repo which installs a framework called Laravel. It is a PHP framework. So it installs PHP, it installs Nginx, it installs MySQL database, and then it installs the Laravel framework, then connects the front end to back end, and does a lot of stuff. So this playbook is fully loaded and does a lot of stuff. So first it begins with doing, so how do we run this playbook? It should be written here in more detail. So how do we run this playbook actually? Clone this repository. So we'll clone this repository on the master server, set up the inventory file. So we set up our inventory file with the various IP addresses we have of our target nodes. Adjust your values on the group vars all.yaml. So there should be a all.yaml file under group variables. So here you define, like if you're installing a certain MySQL server or Apache server, if there is any user that is to be created, what should be the username, what should be the password, and so on. So you define all the variables in this file. Okay, so we will define that, and then first we run server setup.yaml that installs the components like Nginx, MySQL, and PHP. So lemp stands for Linux, which we already have. Ubuntu is there. Then it will install Nginx. it will install MySQL and PHP. So this will be ready for Laravel to be installed. Then we run the Laravel deploy.yaml. So that will deploy the Laravel framework, and then we will access the website on the IP addresses of the hosts. So these are the set of steps that we will do. So once we do that, you will understand better. But now I am just making you go through this so that you understand how this entire playbook works together. So first you do a server setup that installs all these stuff. You set up the variables before that, and you install the Laravel using running this YAML file. And you also have certain roles. So we were discussing what roles are. So let's look into this folder. So as I said, roles are certain tasks which would be called by some other Ansible playbook. For example, here we have a playbook called Laravel deploy, or we have a playbook called server setup. So inside server setup, there are various steps. So here, what are the steps? The server setup files actually calls various roles. One of the roles is to instantiate the setup role, then to initiate the database installation, then to initiate the PHP installation, to initiate the Nginx installation, and initiate the composer files to create the PHP files. So a normal playbook would call the role files, and the role files would contain the details on how to do that particular setup. So for example, if you are installing Docker or you're installing Nginx, you would have to do a apt install Nginx command. So that command would be defined on the roles under Nginx role. So we have a role called Nginx. Now this one again contains some sub stuff like tasks, templates, handlers, and defaults. So normally under the tasks would be a file called main.yaml, which contains the directives of how to install the Nginx. So you have this apt module, and there you mention the module name, and then you do update cache while in doing apt, and then you install this one. So this is how this entire thing works, like how your roles work. So we can go through the other stuff inside the roles directory. One is the tasks, which contains the commands. Then you have defaults, which takes care of certain default settings, and you have handlers and templates. So here we have definitions about them as well. So you know what a task is. Task is a section that contains a single procedure to be completed. Role is a way of organizing the tasks related to be called later in a playbook. For example, in our setup playbook, we were calling a task called we were calling a role called Nginx. And then facts are information fetched by the client system from the global variables. These are just definitions. Like, let me show you what a fact is. Whenever we run an Ansible command, whatever information comes up, like for example here the information came up that the language which we are using is Python, and with our ping command we got a pong response. So these are all the different facts that are discovered by the Ansible engine. Then inventory, you know by now, it's just a list of different client servers or the target nodes where the deployments are carried out. Then comes the play. Play is just the execution of the playbook. So whatever we have in a playbook, there would be multiple plays in a playbook. For example, you have a server setup.yaml, this is one play. Laravel deploy is another play, and so on. And then handler. You have seen a handler directory under the roles directory. So a task which is called only if a notifier is present is called a handler. Let me show you if I can demonstrate this. So inside a handler, you can see it only defines a certain state. For example, if someone defines restart nginx, then it would restart. So it only defines a certain state there. So handler is called only if a notifier is present. So this is the optional one, like it will only be called if someone notifies this state called restart. Only then handler will take care of the restart. We can discuss about handler in depth when we do our masterclass sessions, later on, when you are just studying Ansible, so you will go deep into each of these concepts. But for this particular exercise where you are knowing what Ansible is, you can just know the definitions, and here your prime aim should be to know how to deploy the playbooks. Like you have a playbook somewhere, or you get a playbook from the internet or a GitHub repository. You should be able to make certain changes wherever needed, or and then deploy the playbook. So go stepwise. Next is so we know what a handler is, what a notifier is. Section attributed to a tasks where a handler which calls a handler if output is changed. So this is actually, let me explain in simple terms. For example, you have a service which always has to be on a started state. For example, you install nginx and you have maintained its state as started, like it's always should be started. So in case the service stops or gets killed, then notifier is a module that notifies the handler that the service has stopped, so you can initiate a restart. So that is what is between the notifier and the handler. And tag is the name set to a task which can be used later on, just uh, so that the specific task or a group of tasks is defined. Let me show you what a tag is. It can be like a placeholder. For example, here you see these are the tags. Like when you are installing MariaDB, the tags are MariaDB, DB, or MySQL, and so on. So these are the various pointers which would be called under the particular role. So those are called tags. So for the sake of definition, just you can remember this one. But it will be more interesting when you do the deployments. Okay. So now here is some of the Ansible ad hoc commands which we already did. You can try them on your own as well. Just remember to replace your inventory file name with whatever inventory file name you created, the group name with whatever group you created, and username with Ubuntu if you are using a Ubuntu server, and so on, because these are just generic commands. You just don't have to just copy and paste. Check every switch and option and then run it. For example, this command installs a package called ntp and starts the service, and also prints the current date. This command changes the configuration of a Apache server. So for this to run, you should have Apache installed there. And so these are just examples. They're not meant to be run anywhere, but seeing these examples, you can modify and write your own code there. Okay, so what we are going to do now is to install NetData using ad hoc commands. Why we are going to do this? This is because instead of playbooks, I want to demonstrate you how you can use Ansible to uh, deploy certain applications which using shell scripts. Like this netdata installer is a shell script, so you can use that to deploy your net data across multiple systems instead of using a playbook. So that is what the demonstration is all about, and as for the playbook, we'll do that after this particular installation. So what are the commands that need to be run for us to achieve that? Okay, so here you can see it's on the same notes page, installing net data using ad hoc commands. So here let me refresh the page. So this is the command that you use to install the net data. The first one downloads the particular script into your system, and the second command uh, uses Ansible to propagate it to all the servers and install it. So let's go one by one. So this command would have downloaded the script and put it on the temp folder. We can verify by opening that file. So the script is here. Next would be to run the Ansible that would install the script on both the nodes. Now here something to note is this module named script. So if you run a script module on an ad hoc command, then it would directly run the shell script. So you just have to mention the path of the shell script, and then it runs that script on the destination nodes. So we run them. So if everything works out fine, then we'll have the net data installer working, and net data will be up in both the servers. So let's wait for a while, and if net data is there, we would be able to see the net data on the 19999 port up and running. So you can use this as a net data installation method also. Otherwise, you can also do it using the method mentioned here. Here is a link to a net data playbook, so you can use this to install net data as well. And once that is done, like once the net data is installed and running, we can try out the playbook for the Laravel website. So now the steps in this playbook are not very clear, right? Clone this repo, okay, we know how to do that. Set up your inventory file, we can do this. Change the group variables, we can do this too. Run the server setup.yaml. There's no clarity here, like how to run, what would be the command, and so on. So do not worry, there is an accompanying article also with this particular repo. This is this article, so I have it there on the repo page as well. Like this is the link to that article, so it opens up this one. So here you have all the commands and everything in detail. So you're just going to follow the step 1, step 2, and so on, and the commands that come within that, and that way you will be able to install the Laravel installation in your Ubuntu systems. Okay, so we'll do that installation part in the next video session. For now, let's keep it at here. After we conclude with the net data installation, so let's get back and see what's going on. Still no news, so that means a lot of stuff is going on behind the scenes. So this is one of the disadvantages when you run a shell script using Ansible, because whatever the responses are coming from the shell script would not be visible here until the script has exited. So pass or fail will know in the end. So meanwhile, while this is getting installed, we can just go through what we did and what we are yet to do under Ansible. We knew what Ansible is, how it deploys to multiple servers, how to set Ansible up, and how to deploy using ad hoc commands as well as using playbook. The playbook part is to be done in the upcoming video, and we are already doing the ad hoc commands using Ansible successfully. And apart from that, we knew a few jargons from the Ansible world, like tasks, modules, roles, and so on. So next time we'll we'll run the playbook and we'll learn a bit about what Ansible Galaxy is. So that would conclude our learning phase with Ansible, and then we'll be doing another tool in the next session. Okay, so here we are. So I think it was installed in both the nodes, so we can verify that. So this is our host 1 and this is our IP address. So if I go to host 1 and 19999, I should be able to see the NetData dashboard. Yeah, it's working. It should also work for host 2. So it's working there as well. So that means we were successfully able to install NetData together into different servers, which is a good news, and that's how Ansible allows you to do multitasking. Like you can install a certain thing together, you can configure a certain thing together in multiple number of servers. So we'll continue with the playbook. Stay tuned and thank you for the session today.